what do we have here? We have those on the very bottom. Those are the layers that we get from the Ubuntu base image, right? We create another layer. Yeah. We have to get used to that now. We'll create another layer here by using the work here command, which is up here, right? Then next layer, but this does add 0 bytes, right? Next one, run update update and install build essentials. So line 3 of our Docker file creates that layer, which is 378 megabytes. So we are installing 378 megabytes. Then copy hello.c dot. Here, next layer, 54 bytes. Make hello, next layer, 16 kilobytes. Right? Line 5. So this is how much each layer adds to the total. Then we are running up get remove, and that even adds 1.2 megabytes. Even though we are kind of trying to remove something here, it saves some space. And then if we go further up, rm hello.c, 0 bytes, and then finally a cmd, which is just metadata, also 0 bytes. Now, if we look at that one first, it's a bit simpler. rm hello.c, we would expect that instead of 0 bytes here, we have some negative number, right? But since we are using the copy on write system, means that even if we are deleting a file from that is present in a layer down below, then in this case, this file is copied to the current layer, so in this case, that one. Okay, and then we just say we register the file as deleted. So that's why here it is 0 bytes. It is just metadata that says, okay, this file is deleted, which then makes the container that looks on this layer from the top. It looks okay. It looks at that layer and it sees, okay, this is only a metadata layer, which is CMD. Then it looks one layer down and it sees, okay, we have deleted the hello.c file. So therefore, in this layer, we say store the information hello.c is deleted, and then the container treats hello.c as deleted, so as absent. Therefore, if we check here, there is no hello.c file because the container sees, okay, it's deleted. But since we use copy on write, we do not change the layers that are further down. So we still have this, we still have that layer where we initially copy the C file into the image. So we do not change that layer stays the same, and therefore that layer still takes 54 bytes. And since that layer stays the same, and we're just adding another layer with 0 bytes, then removing files, it does not save storage. Okay? Because essentially, if we add a file, we get one layer, and if we delete a file, we get another layer. So it's if we never deleted the file, then the storage requirements they are like basically the same between adding a file and then deleting a file is the same. That requires the same storage, almost the same storage as adding a file and then just keeping the file. Okay, because we have these layers. Because for every instruction in our Docker file, we create another layer, and each one of those layers has a certain requirement, storage requirement. It's not quite it's counterintuitive, I know, that deleting a file does not release or free up storage space. But the reason is that even for deletion commands, we are adding another layer instead of modifying a layer that's further down. So if you wanted to really delete a file, we would have to modify that layer and remove that layer, because that layer adds 54 bytes to our final image. So if we really wanted to delete, save space, storage space, we would have to remove that layer from our image. But that's something that is forbidden because we are using copy on write. That means whenever we want to write to a file, and deletion is some sort of writing to a file, then we copy the file into a new layer and we modify the file there. So that means that the original file always stays the same. And therefore we cannot release storage space by modifying any file, because the original file will always stay the same. And the only thing we can do is we can trick the container into thinking, okay, this file is no longer there, but in reality, the file is still part of some layers down below. And the same for that command. So, and in this case, we even add a storage requirement of 1.2 megabytes, because during the apt-get remove command, some temporary files, some caching files are generated. And so even if we use some metadata files are generated, so even if we use a command that would normally delete, free up 300 megabytes of storage, since we cannot free up storage but just register for many files that they are not there anymore, but only in this fake way, then we are with some commands we are even adding then more storage requirement, because we are, for example, creating temporary files during the deletion command, or we are using some sort of caching for during that command. And those this cache or those metadata files, they also require a little bit of storage space. So finally, we try to run that command, but in reality, it makes us need more storage space than before, because also that one, just as the one further up, the one with that one, we just trick the container into thinking that those files are no longer there. But in reality, since we cannot modify our layers, since we use copy on write, all we can do is trick the container, but all those files are still there. The files, we can never change the layer that is below. We can only copy files up into our current layer and then say, okay, those files are changed or those files are no longer existent, which is a fake delete. Okay? So all of that is caused by this copy and write system that we are using. Whenever that's why it's called copy and write, right? Whenever we do want to write to a file, be that modify, add, or delete, we copy the original file into a new layer and modify the file there. And therefore, we never change the layer that's further down, somewhere at the bottom. Okay? So we cannot, so we can make the container not see those files by using those commands that we added in. So those files really are not there for the container, but they are still baked into the image. And therefore, if we go for Docker images, we see that this image requires even more storage space than before.
But then, what if you were to do all this in a single layer? Let's say, rather than executing it all in separate lines, you instead copy over a shell script which runs all these commands for you, and then it does the deleting also as part of the shell script. So all of it happens in a single layer.
Yes, then it works. Because in this case, we bake, during the creation of the layer, we create files and then we remove those files again. And then finally, after the command finishes, the script finishes, then we kind of bake the layer into the image, right? Only after the command is finished, then the resulting layer is added to the image. And therefore, if we, a very good idea and good suggestion, and it's also totally correct, if we remove files during, like all in one command, we add files in one command, and then we remove files in the same command, so in the same run statement, then we can make sure that only the necessary files are baked into the image. So, how would we do that with this Docker file? Let's do a little.
Understand everything together.
Yes. So how? I think we should then
Move the copy above.
Move the copy above.
And then everything else just ampersand.
Like that.
Yeah. Ampersand.
Like that.
And the final one, yes.
Like that. That's now 5.0. But we'll have to wait a bit.
No more caching.
No more caching.
टैग कैसे लगा देंगे टैग कैसे चेंज करते हैं
Yes.
तुझे देना पड़ेगा नया वाला टैग हाइफन कोलन के बाद कोई और नंबर दे कुछ और हाँ कुछ और ही है वो वन नहीं है हाँ तो क्या डालूं डाल दिया फिर अभी space dot
Could be. I never tried that actually, but it's a good idea, and that could actually be because the image is static, and you might be able to extract a certain layer from an image, and therefore get that file back. But it's something I have never done before by myself. But it's a good idea and it would make sense. So I suppose that's possible. So in the meantime, let's check if the version 5.0 still works. Seems to still work. And now let's check. Let's do it on a new page. My C.
It's still the same size. No, it's still bigger. No, it's the same size. It's the same size as 3.0.
But should be slightly smaller. My C 5.0. Could be that in new Ubuntu versions, the build there is like the build essential is installed by default. Let me try that again with Debian actually.
Unexpected result.
Unexpected result, yes.
ये मैंने फर्स्ट में वन बनाया, ये दूसरा बन गया क्या? नया कंटेनर बन गया, इमेज बन गया। सेम इमेज तो नहीं है क्योंकि अलग ही है इमेज आईडी,
अलग है,
अलग बन गया।
तुझे क्या करना है?
मेरे को इसका चेंज करना है।
इसका फिर से बिल्ड कर, बस फिर से बिल्ड कर
तो
सब
ये
कुछ, तीनों को बिल्ड कर। जैसे कि नाम देते वक्त वर्ड्स में अंडरस्कोर, वो डीबी का है तो डीबी, वर्ड का है तो वर्ड्स में अंडरस्कोर वर्ड।
नहीं, ये जो इमेज बनाया अपन ने, मुझे इसका टैग चेंज करना है, तो वो नहीं हो सकता। बिल्ड ही करते हो करना पड़ता है। मेरा हो गया आज का। मैंने फोन यूज नहीं किया, मालूम है कितना बढ़ गया तो देख। अरे भाई क्या करना है?
And the previous layers, they still exist. That's why we can't use separate run instructions to decrease the size of our image. Because when we use a layer, when we use an image, then all the layers from that image are used. So, like we saw just previously, when we install some package, right, then we add a few megabytes, and then we remove that package, we also add something, but it's almost zero. So, run RM does not reduce the size of the image. So, we have a few techniques to still reduce the final image size. And first technique is collapsing layers. It's something we just we just tried and miserably failed at.
Actually, I got a. So the thing is, remove doesn't remove the configuration files, and that might be what's causing it. So we can use purge instead.
I tried using it. I mean, let's try. I tried using it with remove dash dash purge.
Okay. And the thing is, because it might be caching the files, we'll have to do an apt get clean as well, or auto clean.
Like that?
Yeah.
That could be it, actually.
Yeah.
Makes a lot of sense. Let's see.
Hopefully.
Would save me some work today in the evening to dig into that.
Save something.
What do I need to do?
Which one did I create? 8.0.
It's on.
Let's
It
see.
was good.
Still big.
Yeah, microphone we don't need. We know to hear teacher. We don't have to.
Alright, I still have to do work. So, then the second option is building our binaries outside and then adding them through our Docker file. Third option is squashing the final image, something we are going to look at, and also multi-stage builds. So let's just review them quickly. So first one, collapsing layers.
Hello,
It's something we tried, and it's something that is supposed to work. But it's exactly what was proposed, in that we just concatenate all the commands using the double ampersand, and therefore we add files in one layer and remove files in the same layer, and therefore the layer is not, we do not have a very big layer. Then there are some pros and cons for that. So first of that works on all versions of Docker, and it doesn't require any extra tools. You can just run the commands. Problems is that it is not very readable, and you see that sometimes it doesn't really work if the cleanup is not thorough. So just as in my example, and as another con is that the build, it takes, like that layer takes a lot of time to build. And then if we make some small changes, like adding a option dash dash purge where there was no option before, or appending one more command, then we have to rebuild the whole layer again. We can also build binaries outside of the Docker file, which looks like that. We just copy the binary to the Docker file during our build. But for that, we have to build the file outside, so it has to exist outside. Can exist in many forms and locations. But we finally, or in the end, we have to create that file somewhere outside of the container, which is in itself is also not very practical, because then you have to install the compiler and all that stuff on your local machine. And through that, you're going to pollute your local machine. So that's something we really don't want to do. But it's possible. in one way at least. So there are some pros. The final image, it can be very small because we are only adding the build file, right? And some cons, we require the additional build tool, and with that we are back in dependency hell and works on my machine, because it depends on the specific machine configuration that you use to build the binary. There are some more cons if you take this binary from a code repository, which are that it breaks portability. If you just, for example, if it's built for one platform, it does not necessarily work for another. If it's a binary built for Windows, it's not going to run on Mac OS without further, let's say, measures. And in general, we don't really want to add binaries to code repositories, because they will take up a lot of space, and we can't really automatically look at the difference between one version of a binary and then another version of a binary. So for example, if you commit some code or some, which are basically text files, right? If you commit text files to a code repository and then you update those text files, and then again you commit the updated versions, then you have a very easy way to compare between the new version and the old version. And most code repositories will even show you the difference between those two versions. With binary files, it's not like that. You will always update the whole file. Another option is to squash the final image, which will then transform the image that is composed of multiple layers into an image that is composed of one layer. And there are two ways to do that. First one is using the dash dash squash during the build. And the second one is to import or export for that reason, the reason that we are squashing the image in the sense that we create from multiple layers only one layer, we are losing a lot of information. So that's one of the cons, and there are a few other cons. We can no longer depend or benefit from the cache. Those squashing operations can take a lot of time, and we also need to actively remove unnecessary files. So just like we did with squashing one layer, or like merging the layers, we ran the command to install, and then we ran the command, we appended the command to remove, right? So in this way we had to do the cleanup manually, and for squashing we also have to do the cleanup manually. But there are also some pros. For example, single layer images, so images that have been squashed, they are smaller and then therefore faster to download. And the removed files, they do no longer take up storage and network resources. So if we use the same Docker file that we used before, where we had 5 lines of run instructions, first one was install, build essential, do some stuff, and the final one, remove build essential, we can squash that image, and then all the removed files, if that had worked, would be gone in the final image, in the final layer. But the preferred and, in my opinion, best solution is to use multi-stage builds, where we have multiple stages in our builds, and each of those stages creates a separate image, and we can then use those separate images to copy files from one stage into another stage. And through that, for example, we have a building stage where we have an image with the compiler installed, with the source code present, and we use that to build our executable binary. And then we have another stage, which is the default, like the execution stage, right? Where we just copy the binary from the building stage into our execution stage, and then our execution stage will be the composing the final image. So we throw away everything that is from the building stage, apart from this one binary that we have built. We are copying the binary that we have built into our execution stage, and then we are baking that into the final image. And therefore, we save all the storage space that otherwise would have been necessary to install all the building dependencies, to have the source code and to have the compiler. Okay, let's look at multi-stage builds quickly before we finish for today. How does it work? At any point in the Docker file, we can just use another from statement. And with that, we start a new stage for our build. And we can use the copy statement to copy files from a previous stage into our current stage. And when we use Docker build and tag the final image, then only the latest stage is the one that is tagged. All the previous stages will still be built and they will be cached, but they will not be tagged. So when we clear the cache, then we really in the end only have the one small final image. There are two ways how we can reference previous stages. So the first way is using numbers, and the second way is using references. So each stage is numbered by default. The first stage starts at 0, second stage is then 1, and so on. Or we use a reference, a name. We can name one of the stages. We can give a custom name to our stages. So let's try to create a multi-stage build for our C program. So let's actually get out of here, copy that, and then we are going to now call that our builder stage. So our first stage. Alright? And here, let's remove that one. We are really running those commands that we know so far. And then we are adding another stage where we reference the builder stage as our base image. Okay. Let's call it the execution stage, or we just ignore that because we are going, the last one is going to be the one that we tag. So therefore, we could either now here use something like that, and then later on, again, reference that, right? Then we have 3 stages, or we are just doing like that, and we have only 2 stages. And then now we use from builder, copy the hello binary into our current working destination. So I think it should work like that, or even without that. Let's see. So in this case, what we did is we changed our Docker file and we gave, so we used the first stage, the compiler or builder stage, right? Then we added my bad, we added a second stage, but we used the wrong base image. And then we copied the hello binary from the second stage to, from the first stage to the second stage, and we made sure that the CFD is still the second stage. So, but what we need to do is,
Right now, it still ends up being the same size.
yes, we need to do like that. And then this one is in /c_code/hello 2 dots. And then command would be, let's do like that, and then we know it works for sure. Alright, then let's see. Here we go. Finally, we managed to reduce the size of the final image again to something like 80 megabytes. Now let's see if that still runs. Yes, it does. So it took us 9 versions to get, but in the end we did it.
Professor, back in the code,
Yes.
even though we are not removing or deleting anything, only thing is we are using multi-stages over here.
Yes.
And how is it able to like decrease that required space and all?
in this, like the last, in this case it's the second stage, but in general it's the last stage, right? The last stage will compose the final image. Okay, and here we use Ubuntu base image, and we add a file from our previous stage using the copy statement. So we have, finally what we have is the Ubuntu base, and then we add the one file. So that makes the total size of the image is the Ubuntu base and that one file. So with that we can reduce the total size of the final image, because we use this first stage here as our builder stage, where we also start from Ubuntu, and then we install a bunch of stuff in here, right?
So these instructions won't contribute to the layering, like the building stage.
Yes. It won't contribute to the layers of the final image. Only the last stage that we use, which is this one that's marked right here, will contribute to the layers of the final image. Okay? And we are indeed building an image from the first stage, but that is a cached image only, and the final image will be composed only of the layers of the last stage. All right, so let's just check that. We see, okay, 9.0, let's check. You see the layers of the 9.0, right? Version 9.0. We have those ones, again, are the ones from the Ubuntu base image. And then we just add one file from our previous stage. So from the other image, we take one file, copy it into this image. And then we have the CMD instruction, which is 0 bytes, but then all of those layers make up then the final image. And those are correspondent to only the final stage. Okay, and through that, we can effectively reduce the size of the final image, because if we now want to distribute that, we only have to upload like 78 megabytes to the to wherever we want to use that image, right? And if we don't do that, then we have to upload the full 450 megabytes. So we are still building an image for that, but that's only temporary and cached. Then we take this one file from the image that we built above, and copy it into our second stage, and therefore also copy that into our final image. So in the end, our final image is only Ubuntu base and this one file. Through that, we can effectively reduce the size of the final image. So in general, when you want to reduce the image size, use the multi-stage build.
So so whatever we do, it would be at most only two layers, like two staged.
No, you can have more than two stages. So we can use now and then put the CMD.
It will further reduce the size.
It doesn't really make sense like that, right? But because we still have to copy that, no, we don't have to, because we are using now the image of the previous one. But in theory, you could have multiple stages. So it's a bad example because it doesn't really make sense. Go back. you can have multiple stages, which would look like then like that. From Ubuntu as in between or something, and then later on you're going from something else, whatever, from Debian, and then you copy from in between, for example. So then you have 3 stages. But again, only the last stage here will compose the final image. Okay? So you can use as many stages as you need.
So initially, what I thought was we need to have a single from like kind of from Ubuntu. If I'm using some Ubuntu, but can I also use like the way you used from Debian?
Yes, you can also use like that.
So it's not mandatory to have a single from. So we can have multiple froms.
Yes, yes. You can even reference here previous stages. So you could also use that. And this you're referencing the previous stage. Okay. Each from is independent from the previous one.
So only at last from will be counted
For the final image, yes.
for the final image.
So the final Docker file then looked something like that. A bit different in our case, but conceptually the same. And we also checked that it works. All right, so with that, I want to finish today's session. Keep in mind multi-stage builds. We are going to use them tomorrow again. I'm going to now upload the slides from today. And if there are any more questions, then please let me know. Otherwise, I want to wish every one of you a nice evening. I'm going to look into why our